Bonus materials. I thought I would try to do a whiteboard of what it looks like when the five principles of Hardy Weinberg are violated in some way. All right, so let's begin by just much like when we saw the picture on microevolution part A of the moth population. Let's say that we've got a population of some organism, and just to make things simple, they exist as three genotypes. All right, so homozygous dominant, heterozygous, homozygous recessive, and we can just count up the number of alleles. We'll just concern ourselves with allele frequencies. So how many A alleles are there? There's or dominant A alleles, one, two, three of them. And how many recessive? One, two, three. The recessive, three recessive. So for this to maintain genetic equilibrium over time, we would expect this population to remain the same. So the next generation would be basically just copy and paste this line over and over, and this allele frequency would remain the same forever. Well, what would it look like if each of the principles of Hardy-Weinberg were violated? So if you recall, the first one is no mutations are occurring. So what would a mutation look like in this scenario? Well, let's say that these give birth to the next generation. All right, so far so good. But let's say there was a mutation, and boom, all of a sudden we've got a new allele. Right? So now we would have to add a completely new allele over here, and it would affect the number of A's. So anyway, hopefully that makes more sense. So a mutation is going to change the allele frequency. Sorry, I'm trying to erase stuff now, as you can tell. Stinking. All right, there we go. So going back. All right, what was the second? Oh gosh, what was the second Hardy-Weinberg principle, y'all? Huh? Population close to migration. So remember that blue jay with an acorn? Let's say he flies in here and he brings an acorn, and all of a sudden, let's say it's a homozygous recessive. So this is the new individual to our population, and what's going to happen is, instead of having three of these recessive alleles, we're now up to five. Right? So that's changed the allele frequency, and you can see how that would violate Hardy-Weinberg number 2. All right, number 3 is the population is infinitely large. So this one has to do with genetic drift. Sorry, my dog's whining. You all right, buddy? What was I talking about? Genetic drift. All right, so catastrophe comes in. What kind of catastrophe you want? A big tsunami. That's a wave. All right, takes those out. What are we left with? So we're left with just these guys, right? Was that natural selection? No. Was it migration? No. It was just a chance event that changed our allele frequency. So our allele frequency would just be all recessive. Number 4, all genotypes survive and reproduce equally. Okay, so let's say for sake of argument that these reproduce the best. So homozygous dominant ones reproduce the most. So that means these aren't going to get a mate as often. These are going to reproduce. And what's your next generation going to look like? I don't know. Let's say it's this. So now what's our allele frequencies? How are they changing? So now we got what? 5? Oh, there it is. And 1. So natural selection has selected for the homozygous dominant and against the homozygous recessive. And in the next generation, we've changed our allele frequencies. So that would be violating Hardy-Weinberg. There we go. All right, and then the 5th one, individuals mate randomly. So let's say that these homozygous recessive ones, I'm going to draw a big heart here, because the ladies like the homozygous recessive ones. So what's going to happen? Well, the next generation, these are going to have greater mating success, right? I don't know, say so. How does that change our allele frequencies? 2 to 4. Right? So in other words, just being able to have greater mating success is going to influence the allele frequencies. Notice in all 5 of these, the allele frequencies began 3 to 3, and then due to whatever mechanism of evolutionary change that we were talking about, the allele frequency change, which is the definition of evolution. So yeah, I hope that helps. If not, never watch this video again. Later.